wonder if I can bring it a little bit closer.
Is she gonna record?
Yeah, I'm recording right now. Okay.
Yeah.
So, yeah, you're on the video. Oh my God, you're so famous. Okay.
Okay.
So there's three different exponential equations we learned, right? There's a of t equals little a, parentheses 1 plus or minus rt, okay? A of t is always the final amount. So whether that is final number of cats, final number of dogs, final number of gum you have, whatever. It's the final amount for all of them, okay? Final amount, final amount, final amount. Okay? A, and P are all initial amounts. So how much you start off with? Okay? Initial, initial, initial. Okay? Okay. And rate R is always the percent. Whether the percent that something is decreasing annually, okay, or decreasing or increasing, the percent. Remember, it has to be a decimal. There's a decimal. The rate. So we know A, final amount, we know the initial, we know the rate. T is time in years, right? T is time in years. How many years, are we looking for the final amount of something? So T is time. Okay. And lastly, in the middle equation is the compound interest equation. It's mostly for money, and this is in the special cases when you see the keyword semi-annually compounded, compounded daily. Monthly, etc. If it's just compounded yearly, it's just n equals 1, and this equation and this equation are the exact same thing. This equation is for simple growth and decay. So anything from your hair increasing 12% every year, right? You having the rabbit population increasing 50%. Anything that is just general growth and decay, anything with the R value is going to be A of t equals little a, 1 plus or minus R of t. Now be careful, if it's decreasing, is R going to be positive or negative? If I decrease in population 50% every year, is R going to be positive or negative?
No.
It's going to be negative. If it's increasing 50% a year, is R going to be positive or negative?
Positive.
Just be careful. Now this is a special case if you see the keyword compounded continuously. And this means that interest is calculated and added every second of a millisecond of a millisecond of a millisecond of a millisecond, etc., etc., etc. So this is for like natural processes, like half-life, or population growth, or height, things like that. It'll tell you that it's continuously compounded. And then what you do, you plug them into the equation depending on what variable. Easy to plug it in for t. If you know A of t, you're going to have to find intersection. So setting your windows and finding the intersections there. Okay, if you have any questions there, you can talk that through. Okay?